Okay, everyone. Welcome to the API work group meeting. We're going to continue on our discussions around Kubernetes. We've had multiple meetings around this now. We actually ate up some of the lifecycle, or I guess the whole lifecycle and provisioning meeting earlier this week, and we're going to continue today. We're going to go over the information that Toshi has provided, which is really around Kubernetes CNI for offloading. So Toshi, if you're ready, we'll turn it over to you and you can go through your deck now.
Sure. Let me share my screen.
Sure.
Okay, I'm going to present Kubernetes CNI for XPU offloading. I made some update since the version I posted before with a couple more pictures. It still has the same design, just to try to explain it better. And please feel free to stop me and ask any questions. It doesn't progress. Okay, now it works.
Okay.
So I thought it helps if I set a baseline for the diagram. And this shows the Kubernetes CNI with a regular NIC. This is how the CNI works today. And this gray box represents the host as the Kubernetes worker node, which connects to a regular NIC, providing one or few NIC interface to the host. And this NIC interface is shared by multiple parts and the Kubernetes controllers are running on the host. So when a user makes the request, like deploying the pod, the request goes to the Kubernetes master node through the Kubernetes API. And then Kubernetes master makes the request to the kubelet as the node controller running on every Kubernetes worker node. And this kubelet calls the CNI plugins through the CNI interface. And there are multiple types of the CNI with multiple different designs and maybe the functionalities. But at the very high level, the CNI basically works just like presented in this picture. The CNI first provision and set up the container network data plane inside the Linux kernel. And this data plane may be OBS data plane or Linux bridge and IP tables or using the VXLAN. There are multiple ways. But at a high level, we can abstract it as the data plane inside the kernel. And since there are multiple ways to do it, so this CNI interface to set up the data plane is the CNI specific. And once the data plane is set up, CNI create virtual network interface to the pod using the guest pair connected to the data plane inside the kernel. And then CNI use the Netlink API to set up the this virtual network interface from the pod network namespace to basically bring it up. And Kubernetes also support other network-related functionalities, such as the network policy as a stateful firewall, and the kubeproxy as the load balancing. So the network policy as a controller running on every worker node, just like a kubelet. The monitors the Kubernetes APIs and basically calls the data plane API to set up the stateful firewall. This may be through the IP tables or eBPF or OVS, depending on the type of the network policy you pick to use. And kube-proxy, this works similarly to the network policy. This also monitors Kubernetes API and set up the data plane to support load balancing functionalities. And kube-proxy is actually the default Kubernetes controller, comes with the Kubernetes upstream distribution. And it supports two types, IP table and IPVS as the data plane type. And some CNI replace it with their own kube-proxy for the other methods, such as the eBPF, for the better performance. So there are multiple types and multiple design. Overall, all the typical deployment use the Linux kernel to provide Kubernetes network data plane inside the Linux kernel. And this leads to multiple challenges or issues. One is this data plane consumes the host CPU cycle, because for every packet, it needs to do the overlay or maybe firewall or load balancing or possibly the IPsec. And it also leads to the limited network performance, especially with the high-speed NIC. And this also increased the security attack face on a host, because those controllers are considered to be a hypervisor for the Kubernetes and set up the data plane that is shared by all the pods. Any question for this page?
I heard that Vipin said that Netlink is more Linux oriented, so this is always all the CNIs using Netlink.
No, I don't think this is recommending that everything has to use Netlink. Only the vEth pair creation is through Netlink, Boris. Everything else from the networking point of view can be CNI specific. For example, using kernel, using kernel constructs or eBPF or OVS. That is somewhat independent, as shown on the right. So all the overlay and all that is not using Netlink in this diagram, from what I see.
Yeah, this is what I read from this. So just wanted to make sure. So Netlink to the left through the
vEth
VFs and CNI specific
creation is quite natural to be done using Netlink. Yeah,
Okay.
because that's happening on the Linux host. But if you were to replace vEth pair using some way of doing hardware vEth pair that I believe Red Hat team was alluding to last meeting, then yes, it would not use Netlink directly.
Right. Basically the CNI does roughly the three things. And this path, setting up the data plane, this is specific to the type of the data plane. So if it is OVS, it uses OVS command to set it up. If it is using the Linux bridge and IP tables or VXLAN, it has its own APIs. But once this virtual network interface is presented, it can use the Linux standard API such as Netlink to set it up. This part is just setting the link state up, setting the IP address, setting the MTU, or setting the routing inside the pod. So that is basically same as how you set up the NIC interface today by using the IP commands. And IP command use the Netlink APIs. But this part definitely is the specific to the data plane you choose to use. Does it clarify or?
Yep.
Okay. So this is the proposed high-level design for Kubernetes CNI, enabling the XPU offloading. So again, this gray box represents host as a Kubernetes worker node, which is connected to the XPU with this L-shaped black box. And this key point in this design is the container data plane I mentioned before is fully offloaded to the XPU from the Linux kernel.
So Toshi, have you seen on this diagram, like from previous slide, the CNI specific arrow goes from the CNI to the hardware offload data plane?
Yeah,
No?
I will explain a little bit later. So, okay, first, basically the point is the this data plane inside the kernel is now provided by the XPU. And we have basically the two APIs used by the CNI related to the XPU. And we used this OPI API as an XPU API to set up this data plane. And the second API is the Netlink API. This is the same. I used to set up the VNIC interface provided. So this VNIC.
Is it safe to say that on the CNI front on the left, there's no change to anything because of the DPU or the XPU? The only change you would see is on the right, where the kube proxy is talking to the OPI API.
Yes, that is basically correct. And but there is some change needed to the CNI, and I will
Could you go back to the previous slide? I just want to understand what was the API.
Sure.
That, yeah. So, is there any reason why the OPI API could not be whatever we have here?
Okay, let me explain the first. So this design provides multiple things. One is the data plane is offloaded.
Mm-hmm.
And this also provides the security isolation between the tenant side and operator side, or between the host side and XPU side, by providing the overlay network, or VPC, isolating the tenant network from the operator underlay network. And host side can only consume the VNIC provided. And this host has no access to the XPU side, which is considered to be an infrastructure managed by the operator. So this host side has no access to the OPI API in this design. And this is the
Does the host
static.
see it as a VF, or does it see it in a different way?
Yes, this can be a SRV VF, or it could be a SIO scalable IO virtualization. So the underlying technology can be, a choice of the vendors. What we need is basically the VNIC as a NIC interface directly attached to the pod. And this VNIC is directly attached to the data plane inside XPU. So it provides the bare metal network performance.
If the pod is running in a VM, what would change here?
It basically works in the same way, but it may require a different way to provision. In case of the Kubernetes, all the worker nodes can share or need to share the same VPC or overlay network, because Kubernetes requires all the pods can talk to any other pods. So that basically brings all the VPC sharing the same, all the VNIC sharing the VPC. Virtual machine doesn't have any such requirement. It doesn't say the virtual machine has to be able to talk to any other virtual machine, right? So
It'll be nice if what was projected here from this XPU to the host was unprivileged PF interface. You should just look at the regular NIC, and so I can just pass it through to a VM, and if a pod is enclosed with a VM, it just gets it thinks it got a device pass through, and not have to worry about, this is a VF and things like that.
right. That's right.
Yeah, but if you say this, if you have 10 pods, you cannot, it's why you should have a VF if you have multiple pods, or, it's not applicable. Or some scenario can be a PF, but only
No, what I'm
exclusive
saying is,
of-
I'm not suggesting it's a real PF. It's the VF. It's actually a VF on the XPU side, but the way it is presented is as if it's a dumb NIC, full function NIC PCI device that just shows up here.
That's right. This basically looks just like a regular SRV NIC to the tenant, and all the offloading functionalities such as VXLAN or load balancing, firewall, IPsec are behind the scenes, completely hidden from the tenant or host side.
So Toshi, in this picture, does the VNIC driver live in the pod? And it's directly controlling registers inside of the XPU to manage its VNIC interface?
Yes. I would probably, it helps if I just jump to this diagram. So this is the NetLink interface. And the basic CNI set up the VNIC through the NetLink interface. And this Linux kernel has vendor supplied NIC driver, which set up the VNIC PCI register interface, which is the vendor specific. So we use the vendor driver to initialize the VNIC NIC interface. But this layer NetLink API is basically the Linux standard API we can use.
In other words, it should use upstream driver from XPU vendors. It shouldn't require anything new. So if those drivers are upstream in Linux distros, and if a pod or a VM is running that Linux distro, then it should be just working fine.
I'm still not clear as to what this NetLink thing is doing here at all, since we're going to be getting a NIC into the VM. And at VM, the kernel that's driving that VM will have a NIC driver.
Yeah.
So
I have the same confusion. I believe, Toshi, you wanted to say NetDev device as opposed to NetLink, because it's a NetDev device there, which is shown as VNIC interface on the host. Is that what you meant?
Actually, I think it is a NetLink is correct. NetLink is kind of special socket interface Linux provide. You can think NetLink as like iOcto if you are familiar with iOcto.
Right. So are you suggesting that this VNIC would be further multiplexed in the pod kernel, that is the VM kernel, to show up as multiple interfaces, and that's where this NetLink would actually go, kind of.
I think it's simpler
Multiplex.
than that. I think that NetLink is just being used to configure things like the IP address.
Yeah. And also potentially create other interfaces if they want on top of the
Yeah.
VNIC.
Right. This is basically the kernel syscall interface and defined as a NetLink spec. And traditionally, Linux use iOcto, but iOcto has several issues. You have to define the command every time. So the NetLink was the enhancement for from the iOctos, but it still basically works like a Linux system call. And the Linux kernel basically acts like the abstraction layer for the VNIC
Right.
register interface through the drivers inside the kernel.
So all of the policy that we're applying out here on the XPU side will be applicable to that particular VF or the NIC that we projected into this pod. And so if we are further partitioning this NIC inside the pod into multiple interfaces to be given to different containers within the pod, all of them would have exactly the same policy applied by the XPU on this side.
Yes and no. Basically, there will be multiple VNICs. Basically, the one VNIC.
Right. If
is
I multiplex on
dedicated
top of a
for-
single
right.
VNIC, I'm talking about that, right? Yeah,
Right,
obviously,
and
if we
the-
got multiple VNICs, each VNIC will have a separate policy applied.
Right. And basically, they all share the same VPC, but the network policy, like a firewall or maybe the load balancing, those type of the policies
Hmm.
can be set specific to the each VNIC because each pod has a different firewall policy associated with it.
Yeah, I would love to see this diagram kind of enhanced a bit to say that, the pods are not running directly on the host. So if we have this notion of pods running within a VM, that would be the use case that is broad. And of course, if we want to get rid of the VM encapsulation because we don't need it, then nothing really changes. But if you have that, VM enclosing the pod, then we can look at, how does the interface that the XPU exposes, how does the host see it? What do we need to run on the host to be able to make that interface visible to the VM that is hosting the pod?
Sure. Yeah, we can basically go the next level of the
Yeah.
detail if we agree on this high level. But in
Tosha, I have
general-
another question on this high
Sure.
level. So I see the network policy and the Q proxy, right? And the proposal here is to create an OPI API to incorporate all the commands coming from the network policy and Q proxy to have the same interface across DPU vendors, right?
Right.
So,
Right.
so on your previous slide, can you go on the previous slide on the how
Sure.
it exists without DPUs? So what is the interface that exists today? Do we need to write our own network policy and Q proxy? Are there any plugins available? Like what is the interface that network policy and Q proxy expect that we can actually implement successfully the OPI APIs to accommodate this network policy and Q proxy protocol?
Sure. I was actually about to explain that part, but basically we can use the same network policy. There are multiple implementations, and we can pick one. Say if we pick the Calico Felix. By the way, the Calico Felix doesn't require the Calico CNI. For instance, AWS EKS used AWS CNI along with the Calico Felix as a network policy module.
So Calico Felix, I think it's the easiest because they have the plugin model, so we can implement the plugin for OPI. That I understand.
That's right. So we can use basically the front end APIs, the Kubernetes API is the same. And the Calico Felix comes with the policy engines, managing all the graphs and relation among the pods. That engine can be reused, and we can simply use the Calico Felix, the plugin mechanism, to come up with the backend as the data plane driver supporting the OPI API.
That's pretty clear. I think that's a good proposal. But what I don't understand is what happens with other network policies that don't support plugin methods.
Right, but I mean, one question here. So you're talking about like dictating what that red box is. That's the CNI specific special sauce. So if you're saying, okay, you're going to use our network policy instead of whatever you've developed yourself, you're kind of just, I mean, you've basically just ripped out what the CNI's special sauce is. Not true. I mean, you're saying we should use Calico's network policy here, but you know, some other vendor or some other CNIs come along and written their own policy, and that's what's made that's why customer A chose them, because they like the way they've done their network policy. And you just said, well, they have to use ours in order to use
No, Billy,
OPI.
I don't think
Okay,
I don't
let
think
me-
Toshi dictates what the policy we should use. He's just saying that if we're using Felix, that they have plugin methods, so we can easily implement OPI APIs into their plugins. If somebody uses something else, we need to figure out how we implement OPI APIs into their network policy. I think this is open question.
Okay, I just want to make sure that we're not dictating that, yes, we should go down the Calico route and use Calico's policy, network policy is what I was saying.
No.
I
I
think
just
instead of having a direct, arrow here directly from network policy to OPI API, it may be worthwhile identifying a separate mapping layer where OPI APIs support a wide class of users, including what is being discussed here. And that set of APIs, we can wrap around something on top of that to be a plugin to an existing, CNI, policy, if you will, right? So OPI APIs, I don't think should be strictly be married to this one particular use case, right? We probably want to use OPI in cases where we don't have a CNI at all.
Okay,
I
why
agree,
you're
but-
absolutely right, and we discussed it. So we started developing two different sets of APIs, and we try to converge them later on. So we start on cloud APIs, which are unrelated to Kubernetes, and we start different thread, which is this one, on specifically on CNIs and Kubernetes deployment. And then after we finish with those two work streams, we see how can we create a one set of APIs that accommodates both, because people explained or were very vocal about that maybe we cannot come with a single set of APIs that come across all the use cases, which are cloud.
No, I'm not suggesting a single set of APIs here, right? I'm suggesting a lower level APIs on which we could build, both use cases, and each of the use cases will bring with them a mapping layer that maps onto this lower
But
level.
how we do it, I don't. This is what the question that I don't understand. If we're using Calico Felix, for example, I understand they have a plugin model. We can implement whatever that we want in their plugin, which is OPI API or another abstraction layer on top of that. But with other CNIs or other network policies, I have no idea how can we make them to implement.
There will
the API.
be there will be a network policy specific transformation code that will
Why
go
would
with the-
why would they accept that? I don't understand.
because they obviously have something like that going today, right? Now, because the underlying infrastructure is not only just supporting them, it's supporting.
Yeah, but they already have the APIs. Why would they change them to OPI?
No, they won't change it. They'll keep it the way it is. OPI will have this
The translation.
Yeah, we will have a translation layer that will be
Okay,
part
so
of
there are two
OPI.
approaches. I agree with you. Two approaches. One is go into network policies like Calico Felix with the plugin models or others and push OPI APIs inside those implementations. Or the other approach is OPI API is not really the API definition, but it's a shim proxy layer that can accept all the existing network policies today and translates it to a single set of APIs. So there is a service that is running here provided by OPI open source community that can integrate with all the different network policies across the universe and translate it to a single XPU specific interface to the data plane.
Mhm.
Am I viewing, Toshi, is that also your view or you have any different opinion?
My view is the basically OPI API should be designed such a way that is not specific to the Kubernetes use case.
Yep.
I'm just trying to list the necessary functionalities in the next page for the OPI to support. And once those functionalities are provided, we can basically have the network policy or kube-proxy controllers. The implementation is the choice of the vendors or choice of the user. One may choose the Felix or the other vendors may choose a different one. But this is basically acting as the controller between the Kubernetes and OPI. And as long as we agree on the OPI API, I think that is the flexibilities available.
I believe it's not enough, Toshi, because defining the APIs is never enough. If you don't show the actual example of how you integrate with network policies or even implement one, either reference implementation or example implementation to one of the network policy, for example, I don't know, Calico, Felix, whatever, then those APIs are just, without any use case, they're just defined out there. I don't think it's enough.
I completely agree to work on the POC, and we can pick one. And I do think Calico Felix is a good one for the POC. But what I mean is design doesn't dictate you have to use the Felix. So, but as an OPI, we can come up with the Felix as a reference implementation, but it doesn't mean you have to use the reference implementation, right?
I'm still unclear regarding the approach, whether we go and try to make changes in the existing network policy implementations, or we accommodate all of them by implementing a service that does the translation.
Yeah, I would think we would put a translation underneath network policy and even kube proxy.
That's what's happening today, right? In some sense, because
Yeah,
every platform that is currently running any one of the CNI policy engines, they all don't have the same interfaces. I mean, we have different ways.
I think I would like to correct you. So when you said it doesn't have the same interface, but the Kubernetes API defines the how network policy needs
the
to
north
work.
side APIs are fixed. I get that, but I'm
Right?
talking
So this
about
front end is basically the same, and
exactly,
Kubernetes basically provides the flexibility for how you implement the controllers based on the API that is defined, right? And also the Calico actually extend APIs. They actually come up with the extra information, extra policy outside of the Kubernetes spec. And I guess the other vendors may also come up with the additional network policies. I think that kind of flexibility is allowed. But as long as the API provides the necessary features to set up the stateful firewall, that kind of vendor-specific policy extension can be accommodated using the same set of the APIs. Such extension is like a policy. You usually need to specify the part or namespace as a label, but Calico, for example, provides like a global policy that applies to all the parts in the cluster. That part is the specific extension of the Calico, but it doesn't require the extension to this API layers. It's just how you manage the policy engine inside.
Ben, you got your hand raised.
Yeah, thanks. I mean, of course, the devil is always in details, and I agree with what Boris was saying. I think once we try to look the southbound of these red blocks in the L-shaped DPU, XPU thing, we will come to the dilemma that I was probably describing a few months ago, that different CNIs use different southbound APIs, whether we like it or not. And different DPUs use, to your point, KY, all DPUs don't use one single data path either, and so therefore trying to, without going into the details, different things work differently. Let's just put it this way. I mean, whether it's P4 or some kind of flow lookups or something, but it's not exactly the same. So trying to standardize an API across all DPU vendors for Kubernetes, the lowest common denominator is the northbound APIs to those red boxes. But this means we can't leverage the existing CNIs. And that was the dilemma I was discussing probably a couple of months ago as to what we are up against here.
So, I mean, if you put the burden of providing a shim that abstracts the DPU specific details in the southbound path, and get to a place where, you know, there will be multiple shims that would work with the existing CNIs because you don't want to change them, right? So it's a bit of a heavy lift in the sense that there are two places where we need to normalize.
Correct. Correct. So in that case, each XPU vendor will have to implement a shim layer for every CNI because
Every CNI, it's a combinatorial nightmare. But
exactly, yeah. So there are like, let's say 4 DPU vendors and 3 CNIs. You're looking at 12 possible things, which is okay. I'm again, you know, I don't have a perfect answer for this either.
but you know,
This eliminates the need in OPI, Vipin,
Right, but
because
hold
then
on.
GPU vendor can implement its own proprietary APIs to the specific CNIs without going through OPI. So OPI provides no value here in that
No,
case.
so hold on. I mean, the problem is there today, right? It's not a new problem that created. We have this problem today,
Yeah.
and so, you know, yeah,
But we're trying to solve that problem, right?
we're trying to solve the
If
problem.
you create a middle layer that's an abstraction layer, so that it's equivalent to cross-compiling to bytecode and then recompiling to the target, right? So if we have shims to the different CNIs that take it down to a common API description, and then we have the shims to the individual DPU vendors on the southbound, that's what we've done. It's a two-step process, but it gets rid of the having to support all the combinations as unique things.
But who will support that team? That's a very heavy lift. I agree with KY. Implement shims for all the CNIs that we are going to support, it's impossible.
No,
CNI
I mean,
vendors will not.
if you're a vendor who's in love with that CNI or an end customer, it's in your interest to participate in OPI to help get that shim built for that CNI. If nobody cares enough about that CNI to make that investment, then it won't get done.
But why would they go through the OPI? I don't understand. If they care so much about that CNI, they will implement proprietary to their CNI with their proprietary DPU vendors. Why
But
to
if
go through
they
another
do
shim?
proprietary, then they're vendor locked to 1 or 2 DPU vendors or versions of DPUs. Whereas if they go through the OPI path, their CNI will suddenly work on all the DPUs.
And what this brings me to is, you know, let's not make good the enemy of the perfect, right? So there are other areas of this OPI API in this picture that are not as controversial as trying to match, you know, 3 or 4 DPU vendors with a number of CNIs that are out there. Even if we didn't address the southbound APIs coming out of these policy engines, there's still the provisioning part, you know, the management of this thing. Those are all things we can standardize on, and then look at how this southbound APIs can be gotten to a place where, at least if we can show the problem is a little bit more tractable than what it is today. If we didn't do anything, what's going to happen? That's what we need to compare against.
I mean, that's the approach we've been following, Boris, for things like storage, right? Where we used SPDK as the common layer, and then we built individual shims to the different DPUs.
But that was easy because there is no network policies that we need to accommodate. We just built an API that anybody can consume because there is no standard in storage for driving API. So that was easy. We created shim layers to the specific vendor implementations, different DPUs, that's true. But on the northbound, we only have one set of APIs and we don't have a problem who consume that because nobody can consume storage today. There is no standard. That's easy.
An equivalent of that would be the northbound APIs that these red boxes are exposing up to Kubernetes. That's the real equivalent. In other words, I'm not suggesting we do that, but in that case, because that's one consistent interface going to the DPU, and those could be effectively, you know, merged into the gRPC APIs that we want to commonize.
So implement OPI network policy and OPI
All of
policy.
I'm not suggesting implement all of it directly, but we can take and define that, you know, define that bottom layer, which we all can agree upon to be high enough that we all could agree to implement as one API. across all vendors. And but the main problem with that approach really is that it doesn't fit the bill of existing brownfield CNIs. Otherwise, I think it will be common thing. It will work across all DPU vendors just fine. But what happens to existing deployments in brownfield CNIs? That is the only question, because then we are forced to think about the current CNIs and their roadmaps on how they are planning to enhance, and then keep on chasing those southbound APIs corresponding to those things.
I think you could probably do that for kubeproxy, what you're talking about, but for network policy, I think Cube is still a little behind or still defining. I think a lot of the network policy is, like was mentioned before, are CRDs, custom resource definitions on how to set up policy.
Yeah.
So it's less standard and more proprietary for policy than something like kubeproxy, which is, you know, your service abstraction. It's a little
Yeah.
more well defined.
Yeah, I agree with you, Billy. I think
Yeah, I agree.
that's how I see it.
Wha-
And then there are more features too. I think it's not just about, you know, these two blocks, network policy and kubeproxy. I mean, there are CNIs that offer features beyond these. And so you are in that chase. Like, for example, if someone's offering encryption a certain way, or someone's offering mirroring in certain way, or someone's offering monitoring in certain way. And so I think those red boxes are not just two, there are like n number of those, and we have to evaluate each one to see how that looks like. And
But yeah,
But
because
those
there's
orders
ingress-
are-
I
there's
think
ingress
those
and-
red, go ahead, sorry, Donald.
I was just going to say there's ingress and gateway and things as well that the CNI often participates in.
Yeah.
Um,
Yeah.
I do think the red
unfortunately-
boxes are a good start. I mean, I think that's a good fundamental basics. There are other stuff on top of it. I totally agree, but I do think that's like the core.
Could we go back to the previous slide, please?
Senthil has hand raised.
Oh,
Yeah,
sorry.
so now I want to agree, right? But I just want to bring up another point as well. So most of the, right now, if you look at telco and others, they're all looking at multiple interfaces, not a single unique multi-CNI kind of thing, right? So how does that is getting addressed in this design?
Yeah, you can support multiple NIC interface attached to the pod. It doesn't dictate it has to be a single. It's just saying you could use this VNIC for the primary network interface. You could also add Multus and support multiple VNICs attached to the pod.
Okay.
Yeah, I think, you know, Senthil, the Multus use case is very, very simple compared to this. All Multus asks for is a VF interface in addition to whatever pod does on its regular CNI. So you have two interfaces, one for management of the pod or communication and control and management part, and the second one is for data path. And if you separate these two and use data path APIs only for the acceleration and all that, that simplifies it tremendously, because you can continue using CNI A, which is your primary CNI for most of these things, and use Multus for VNF or CNF functions here. But here we are not talking about doing just the CNS. We are talking about offloading the base functionality of what a regular CNI does for network policy and all that in the DPU itself.
Yeah, I understand that. The reason I was asking, right? So yesterday there was another configuration meeting in another open source community in FIO, right? So about talking about sub interfaces which are required, how like how we talked about network policies are mostly CRD. So now they are talking about additional sub interfaces. Those concepts, whatever networking concepts we are discussing in traditional networking, those are coming in place for providing those abstractions, and additional CRDs are they're talking about additional CRDs, right? That's what I.
Yeah. In fact, you know, the reason these discussions can happen and still be okay with it is because the use cases are different. Like for cloud use case, you don't want to have any tentacle going into the pod or anything without going through the security construct of the DPU, for example, right? Whereas in service provider, the entity that is running up the host is a trusted VNF, CNF, whatever, right? So it is possible to use Multus in service provider use case, but definitely not in this use case that Toshi is describing.
So we have
Thanks.
the 10 minutes left. Toshi, if you want to do a few more slides before we continue the questioning, that's fine, because we want to finish your presentation today.
Sure. I think I made most of the point, and I was I think talking this VNIC is directly attached, so it provides bare metal network performance to the pod to the bandwidth VNIC provides. And basically, this shows the static provisioning case. So the data planes and VNICs are pre-provisioned. So the CNI only needs to do the initialization. And the controller part we I think discussed. And next page, this shows the 4 main functionalities API needs to provide to support this design. For each categories, it doesn't mean there has to be a single API. I expect each category of the function associate with a set of the APIs. First one is to provision the VPC. This is to set up overlay networks such as VXLAN by setting the tunnel endpoint underlay routing. This could be a static or a dynamic with a BGP. So basically, the goal is to set up the data plane described in the previous picture inside XPU. And we can also set up the IPsec for encrypting the underlay network, such as VXLAN over IPsec. This IPsec is not required for the CNI to work, but I think it is the key functionalities XPU should support. And the second feature is the provision the VNIC. This is to allocate the VNIC as the SRIV or SIV virtual function, which is the layer 2 NIC interface in the overlay network. And I think the API needs to be flexible enough for the vendor to choose the what underlying technologies like SRIV or SIV they want to support.
And I remember Billy was mentioning scalable functions as well. Is that falling in the same category? Scalable functions is sub-function.
Right. I think this is similar to the SILV. And yeah, I think it is a choice of the vendors. As far as the API is concerned, the required functionalities to present the VNIC to the host.
Okay, just checking.
Boris, is that bullet fall more under the provisioning lifecycle of getting the card booted and getting your set of interfaces initially set up, or does that really fall under API?
Don't you want the dynamic as well, provisioning of the VNIC? Like if you want to plug in hot plug and new virtual functions, like that would be not part of initial provisioning, right? That would be later on.
Yeah, it's not really provisioning and lifecycle the way the provisioning and lifecycle subgroup kind of scope is defined.
We can definitely think about that, Billy. I'm not set in stone either way. I'm just saying it's a good slide to, yeah.
Yeah, just something to think about whether we need to address some of that or not. Just all right.
No, I'm saying that the provisioning things like the VNICs should be part of the API definition for mostly for the dynamic creation and deletion of them, but it ties so much into the networking configuration as well.
Yeah, I agree with the dynamic part of it. It's just that depending on the technology used with something like SRV, you have to go in and say, I want 64 VFs, and that has to be done initially before you do. And then I think the card has to be rebooted and then come back up. At least some of the NICs work that way, right? So
I agree.
They do. You have to go in through the BIOS and get all of that set up. That's
right.
correct.
So depending on what you're doing, some of that type of stuff would be day zero. The dynamic nature of it, I agree with, would fall under this. So anyway,
I agree.
Yeah, dynamic provisioning needs to be an API that has to be in there so that you can go in and say, I might have allocated 64 SRIOV support, but I'm only going to set up, 12 VNICs.
Right. So this is why I didn't say it has to be a static or dynamic. I think it is a choice of the vendors if they want to support static only or go for the dynamic as well. And I think the SIOV makes it a little easier compared to the SRFC. But the point is the feature at end state it needs to be able to provision the VNIC in one way or the other. So. And the third functionality is to set up the stateful firewall or ACO. This is to set up the ingress and egress stateful layer 3 and 4 firewall. If you are familiar with the AWS, this is the functionality similar to the security group you can attach to the EC2 instance. And fourth one is the stateful load balancing. This is to set up the layer 3, layer 4 stateful load balancing with DNAT and SNAT functionalities.
So you would look at this, Toshi, as 4 categories of the networking APIs that OPI should look into in each space, implement and suggest the specific RPC calls, right?
Right, and the RPC call or API may be a set of the APIs providing this category of the functionalities. I don't say there has to be a single API for doing everything. So that's something we can define. But at the end of the day, that set of the API needs to provide enough functionalities for setting up like a stateful firewall or maybe load balance, so that basically the CNI can use those features to offload the functionality required for the Kubernetes.
And if you go to the previous slide, I just want to make sure I understand, what Billy and Donald presented last time is they want to offload the CNI itself into the DPU and then have the CNI shim instead of this red CNI box. So this is not the same approach, right? You still, in this high-level design, you're still running the entire CNI on the host itself and not inside the DPU, correct? Billy?
Sorry, I didn't follow the question. And when you said entire CNI, does it include the CNI in the strict definition? This is only the CNI. A CNI package may come with the additional controller, such as network policies. And CNI has to, this plugin has to run on a host because it has to be called from the kubelet and it has to run in a pod namespace.
I understand. So right? Billy, like you presented, this is going to be the CNI shim, the new CNI?
Yeah, so I mean, I think we're semi on the same page here. So yes, what his red box there is kind of our CNI shim. And I think I did specify that a lot of CNIs take the network policy and kubeproxy. They don't necessarily run kubeproxy and they absorb it into what I called an overall CNI. It's the same, you know, here he's got 3 boxes. We had more of 1 box. So in that sense, you know, I think it's very similar.
Yeah, okay, so that helps clarify. If
yeah, and I think he did specify that somewhere in one of his bullets that some of the CNI plugins do take care of the network policy. I mean, he had it in text. So I think we're semi on the same page. I do think where his CNI boxes, there's a little more complexity there. And the fact is you need to have some handshaking with something in the DPU to know what VNIC has been given to a pod and how to, so he knows what to plumb into the pod. So
but if we want to do the isolation, we don't want CNI to communicate directly to the DPU, right? So that would be through the Kubernetes master, right?
That's right. And I was thinking of some type of like CRD,
exactly.
OPI CRD to exchange that information. But there is something he needs to know how there's some handshaking that has to be done there.
Right.
And you have additional complexity if you wanted to put the entire pod down into the XPU also. Right, because then you'd need to have the kubelet and the CNI go in. Is that correct?
Yes. If you're going to run pods down on the DPU, now depending if you're wanting to use Kubernetes down there, which I would like to use down there, then yes, you would need a kubelet down there and as a CNI down there. You could run pods directly using Podman or something else, but I mean, then you have to write your own lifecycle management of those, which you've got Kubernetes for that. So. That's
Right
why I
on.
would want to run a Kubernetes down there.
Okay, yeah, go ahead, Toshi, sorry.
Yeah, for the VNIC allocation or assignment, I didn't put in this picture the next details, but for the static provisioning, we could use existing mechanisms like SRV device plugin and manage all the pre-provisioned VNIC as a resource attached to the host, and have the scheduler basically check the resource available and use the plugin, device plugin to assign the which VNIC to be attached to the pod.
Right, right. Once again, I said a handshake because what's happening there is it's actually the decision on which you give it you say, here's my 64 VNICs that you can use. And then it's up on the host that decision is made. Our CNI doesn't have a choice in it. It says, hey, you go use number 32. And so we need to get that information back down to the DPU so he knows which one to plumb up. Once again, I said it was kind of like that handshaking on which one to use needs to be done.
Yeah, Toshi, if you don't mind, we can maybe extend this to mention it specifically, the CRDs between the CNI and DPU handshake style, something like that.
Yes, and I think it depends whether we use static or dynamic provisioning. And in case of the static, we can actually pre-provision to set up the overlay network for the VNIC. Then what it has to do from the host side is very limited. And to set up the IP address, there are also the multiple ways. Typical CNI has the IPAM and basically managed IP pool by itself. But in case of the provision, we can basically have the IP and MAC address association provisioned at the same time and run the DHCP server inside XPU. So we can use the DHCP client IPAM, which simply get IP address from the DHCP server running on XPUs and assign. So that way, we don't have to also dynamically update underlay routing or association between the VTEPs. So many things can be statically provisioned and avoiding the communication between the host and XPU side. Of course, there are cases we may want to set the traffic shaping according to the bandwidth allocated to the pod. So that may have to be dynamically set. Such case, there needs to be a path to the OPIs to set up the traffic shaping. And that could be an inbound path using the maybe NIC command, or it could be the out of band path somehow going through the basically around the basically management network. And for the cloud environment, free managed Kubernetes master may be managed by the operators that also secure the connection between the master and XPU.
Okay. All right. Well, we're at time. So I guess we need to start flushing out some more of the details, start looking at the different ways that we need to do the provisioning, the setup, what the different shims may or may not look like, and how we need to drive this forward. So thanks everyone for joining today, and we'll continue the discussions probably next week, unless we want to take away more of Boris's provisioning.
But Mark, we need to come up with concrete proposals for next week. We cannot just start the discussion all over again next week. We need somehow to start working offline, and maybe Billy, Toshi, we can work offline to understand where we're taking this. The overview is great, but now we need more concrete things.
Yeah, Toshi, can you send your updated deck to the get into the GitHub with the overwrite the one that's up there with this newer deck?
Yeah, I'll post to the Slack channel right after this meeting.
Cool. Thank you very much.
Okay, I'll pull it in.
Thanks.
All right,
We can
thanks
use
everyone.
Kubernetes channel to have offline discussion and conclusion. So I think that would be a good idea.
We should do that. Start
Okay.
figuring out what these shins start to look like and start moving forward on that.
Sounds good. Thanks.
Oh, sorry, I know we're out of time. I had a quick question. Has anyone played around with, like, I don't have any DPUs on like simulating, like running 2 VMs and trying to run some interfaces between them to act like the VFs. Has anyone thought about it or poked around at that?
Yeah, I run several VMs on the host with different virtual and physical functions from the DPUs.
No. I'm saying I don't have a DPU, but I'm trying to think of a way to have some type of
Simulate.
simulator, so I can poke around and deploy Kubernetes in 2 different places and try to get them. But what you really need is to plumb interfaces from one to the other, so it kind of looks like it's. I just didn't know if anyone had played around with anything like that.
Like we do with
So
Virta.io and
Intel did
QEMU.
that.
I think
Sorry.
there is a sim in the Dash project. I have to go back and check. But there is a simulator in the Dash. There is a P4 sim available. Maybe that could be used, is what I guess.
But it's
I-
very specific to Dash use case.
Yeah,
But
yeah,
yeah,
that pipeline is
it's a
specific.
virtual one. Yeah.
Yeah, that is very public to Dash use case. I agree. But at least there is a simulator P4 pipeline simulator, and that can be a little bit modified to achieve your use case. I don't see any other options at least available right now.
Okay.
Unless Vipin, Vipin or anybody, the DP vendors, right? They have a simulator, so then that's another
Yeah,
option.
I was thinking in the background. I don't know if the kind of simulator is there, or at least I don't think we have it here at AMD. Which can, it's conceivable. You can work on it, but we don't have it.
But I don't understand why not emulate with QEMU. Having your virtual functions presented from different VMs.
But you need the Boris. You will need QEMU device simulator as well. In other words, for example,
Virta.io.net, no?
if you support Virta.io.net, yes, you could use that.
QEMU supports Virta.io.net, so it's good enough maybe for Billy.
Okay. I mean, that might be an option. I'll have to poke at that a little bit and see.
This is what we do with storage. We deploy for emulation, we deploy QEMU, we do Virta.io block, and we plug in automatically devices between the emulated VMs and the host, and with gRPC and all of that stuff.
Okay, let me poke with that a little bit and see if that gives me what I want. I'm not sure what I want right now, to be honest with you. I just need to start poking around and writing code. So I kind of was trying to think of a development platform to simulate running like on a host and in a DPU.
Yeah.
Okay, thank you.
All right, thank you everyone. I'll close this out.
Thanks.